Okay, this is part 2 of Peak Pixel Logic. So, we already went over the general rule that I want you to understand, because that solves 90% of the puzzle. Now we're just going over some specifics. Just going over this particular example and showing a few things. For example, what I said is, when you have two squares like this, you want to ask yourself if you know you can conjoin them. In this case, if this one was a separate block of 1 and these are open on either side, you can't fit the 3 on the top here. Obviously, I'm explaining that very elaborately, but you could see that straight away. Like, obviously, you can't fit 3, so you know this one is 3. This one as well, you can't. 8 means that it's all the way from over here. We actually know this row entirely because 1 plus 8 plus the space in between is 10. That if the minimum group size is equal to the grid size, obviously there's only one solution, so you can fill it in straight away. 322 I spoke about earlier, right? 322. We have 9 minimum group size. That means we can take the topmost configuration 1, 2, 3, and we know that one. Space in between 1, 2. Take the bottommost block. Space in between 1, 2. This one, right? So this one is essentially, if you want to verify, remember, that's the overlap between the 2 on the top here and 2 at the bottom, right? And there's no other way of configuring it. Here we know this one needs to be conjoined, and then we have this one set up. We know these are conjoined because this is a single group, so no worries there. This one's already done for, so you just fill that in on the left side there. So you know the 2 can't be over here because you can't fit the 1 in between somewhere. That is a very common theme, right? Like whether you want to fit something on the left or right side of some columns or squares that you need to leave empty, that you know you need to leave empty. This one, for example, needs to be left empty. I didn't fill that in yet, but it's already been established by the logic of our puzzle. Can fill this one in, fill that one in. 3 and 2, we already got that one set up. Can only go in one direction here. The space is bound to go towards the bottom. It's the same thing we saw at the 4 over here. You know something, if something's stuck on the left side, it can only go to the right. Here the same thing, and now we know the entire group in this instance because of that. Obviously this can't be conjoined, so it needs to be on this side. Oh, whoops, almost made a mistake there. This one can't go to the right, so it needs to go to the left. Here you can't fit this one in here because that would screw up this pattern. So you gotta fit it over there. This one needs to be conjoined. Put this one over here, put this one over here, this one over there, this one over there, and we screwed something up somewhere. There we go. I just made a tiny little error at the end there, but the tooth monster. Ta-da! Now let's do one a little faster. For that I need my tablet because my mouse is screwing up a little bit. And let's do one fast. Demonstration time. I haven't perfected this yet, but I'm getting there. Yeah, we'll just try it out. We'll just see what happens. So 7, that's like 3 in the center, right? Oh, what? Okay, so that is actually 4 like this, right? So actually this is a 9 grid, isn't it? No, it's 10 actually. Yeah, 3 spaces on top. 10 minus, yeah, I screwed it up there. Just some calculation errors. Yeah, my tablet is not working with me here, but I'm just gonna do this to the best of my abilities. 4 and 4 means you have 3 overlaps, so 1, 2, 3, 4. And on the right side you can do the same thing, right? It has to be symmetrical. Look at these little things, they lag out. That's really weird. You can do the same thing for all the other ones. This one needs to go towards the bottom. This 4 block, it can't go further to the top. It would always have this one filled in both configurations. This one has to go towards the bottom, which means this one is now this row is now completely closed off. That's good. This one, we know there can't be square there, so we can just fill that right in. Can't be anything on the left side here. Again, I'm getting kind of stressed out by my tablet lagging out, but it is what it is. If the 1 is on the leftmost side, so leftmost configuration, 1 space in between, here the 4 starts. Then you go to the right. And again, all these squares are then overlapped, right? So you can fill these ones in. Alright, let's keep going. At the top here, we got 3 and 2. I don't know a whole lot about that yet. These are mutually exclusive, but that doesn't give me any information just yet. let's see, 4, 2 in this space, 2 and 1. So that's on the bottommost. If this 1 is at the bottom, square in between, you only got 3 potential spaces for the 2. So the center one has to be this one. 2 and 4, that means this one has to be all the way over here. I already could have known that if I paid attention to it. That means all these are empty. And that actually gives me a lot of information, because then this one has this one block here, needs to be on this side, and that solves the entire thing. It just, now it's like a grid of size 9, and this has 9 blocks, right? Or 9, the group size is 9, right? 1 plus 4 plus 2 is 7, plus 2 spaces in between is 9. Alright, let's keep going. This one is solved. That's actually one I want to fill in like this. Then we know that the 2 is over here. This one can't be conjoined, so we already know it has to be on top here. And that means that we can only move... See, we can't move too far to the right here. We can't... Which means that all the configurations are in this space, which means we can fill in this little block over here. 4, 1, and 7, 2 is now solved as well, which means we got to fill this one in over here. We only have 3 spaces remaining, so we know this central one has to be like that, right? You got 1, 2, 3 spaces for a block of 2, which means you gotta 3 minus 2 is 1, right? So just leave 1 space open on either side, fill in the central block. You gotta realize this one over here, this block is not part of the space because it can't be filled in, right? So it's these 3 blocks. Alright, 9, let's see. Oh, right, this one needs to go over here, so this one we know then. And this one can't be filled in, so it needs to be towards the bottom here. So we got these 2 as well, and this one. And that's it, that's puzzle solved right there. We'll do one more and then call it a day. I need to be a little faster then. Alright. This looks like an easy one. Lots of 10s. Lots of 9s. And then it might get difficult. Oh, and the grid size is greatly reduced. It's 9 on this side. Oh my goodness, this is going to be a walk in the park. So, like this, like this. This is actually the only thing that works. 2 and 4, that actually is already limited as well. 1, 3, and 1. That could be over here, so I don't really know. 2, 2, and 1. I mean, this is just, oh. Like this. And then we fill in these 2. And that means we know that, let's see, 1, 5, and 1. Yeah, we got that one solved. 1, 2, 2, or no, we don't know whether it's on this side or that side. 4, now we know. 1, 3, and 1 on this one. 1, 3, and 1 here has to be over here. This one goes over here. This one goes over there because that's the only space optional. That's it. That's a quicker one. At this rate, we can actually solve the last one as well. Let's do that. Save all these in my repository, and let's see. Because I haven't seen any of these, just in case you were wondering. That would be cheating. If I saw one that I recognize, I would tell you. Because there's just no point. Okay, so let's see. Do I have any inferences over here? Whew, this looks like a hard one. This one looks like a really tough one where you have to break through somewhere. This one is a 1 block, so we know this one is 1 block, so we know this one is 1 block. This one we don't know. Okay, so let's see if that helps us at all. Doesn't look like it helps us too much, though. Well, oh, these 2 are limited because we already know. Oh, right, we know these central blocks are all like crossed off, like for these ones at least. And here, you know, it's restricted because you can't fit 1 group. So if this were the 3 group, you can't fit it. You can't fit the 1 block anymore. Let's see. Alright, so I'm gonna run out of time. I hope you enjoyed the demonstration. I can solve this problem at this point because the grid is quite constricted at this point. Anyway, so hope you guys enjoyed it, and hope you guys enjoyed puzzling around and using some of my techniques. And hopefully like and comment if you noticed anything that was off, or if you have more tips and tricks that I missed out on, let me know in the comments. And subscribe. Also, big one, hit the bell, anything, you know. Just do the whole shebang if you're at it anyway. Alright. See you guys in the next one.